If you're a senior AI engineer and your agents keep failing in production, not because of the model, not because of the code, but just because they don't have the right information at the right time, this video is going to fundamentally change how you think about building AI systems. There's a phrase spreading through the AI engineering community right now. Andre Karpathy said it. Shopify's CEO repeated it, and Gartner has now made it official. The phrase is, prompt engineering is the wrong term. Context engineering is what actually matters. The numbers back this up completely. 82% of IT leaders say prompt engineering alone is no longer sufficient for their systems. A peer-reviewed study ran 9,649 controlled experiments and proved why. And 95% of data teams are now actively budgeting for context engineering training this year. This is not hype. This is a fundamental architectural shift. And in the next 25 minutes, I'm going to give you the full technical picture. The 5-layer stack, the 4 core operations, how it changes agentic system design, where teams go catastrophically wrong, and a concrete 3-week plan to implement it. Let's get into it. So what exactly is context engineering? The most precise definition I've found is this. It is the systematic design, curation, and management of the full information ecosystem surrounding the model, not just the words you type. Prompt engineering asks one question. How should I phrase this? Context engineering asks a far more important question. What does this model need to see? In what format? In what order? At what moment? To produce a reliable, accurate, useful output. It breaks down into 3 core disciplines, shown on the cards here. The first is select. Retrieving only the minimum relevant context for this specific task right now. Not everything you have. Not your entire knowledge base. Just what this task needs, at this moment. The second is store. Persisting context to memory systems between sessions. Because nothing important should live only in the context window, which vanishes the moment a session ends. The third is manage. Compressing, summarizing, and prioritizing what enters the context window. Context windows are finite. How you fill them is the difference between an agent that succeeds and one that slowly degrades and fails. These 3 disciplines are the foundation everything else builds on. Let me be direct about why prompt engineering hit a wall. Because understanding the failure mode matters more than just accepting the verdict. Look at the left side. Prompt engineering makes one core assumption, that if you word the request correctly, the model will figure out the rest. That worked when LLMs were essentially sophisticated autocomplete. Single turn, simple queries, small context windows. But 3 things changed simultaneously. Models got dramatically smarter. Their reasoning has largely solved the problem of understanding what you're asking, even with imperfect phrasing. So the phrasing stopped being the bottleneck. At the same time, AI moved from single-turn chat to multi-step agentic workflows. In an agentic flow, there is no reprompting. You can't course-correct mid-task. The context you load at the start is all the agent has. And third, the real bottleneck became data. A perfectly crafted prompt is completely useless if the model doesn't have access to your company's actual data, your current system state, your decisions and constraints. DataHub's 2026 report put a number on it. 82% of IT leaders now say prompt engineering alone is no longer sufficient. The right side is the answer. Context engineering designs the entire information environment. It controls what the model sees before every single call. And critically, unlike clever prompts, which give diminishing returns as models mature, context engineering compounds in value as your systems grow more complex. As Andre Karpathy put it directly, this is what actually matters. Now let's get into the architecture. The mental model I use for every AI system I design is the 5-layer context stack, shown here from top to bottom. Layer 5, user message. This is the runtime input, what the user actually types, or the event that triggered the agent. This is the layer everyone obsesses over. It is the least important of the 5. Layer 4, Tool results. The outputs from API calls, web searches, code execution, injected into context at the moment they happen during the task. Not preloaded. Injected dynamically. Layer 3. Retrieved context. RAG retrieved documents, memory lookups, database records. Only what's relevant to the current task. This is the layer most teams think of when they hear context engineering. But it's one layer of 5. Layer 2. Conversation history. The accumulated record of prior turns, compressed and curated. I'll come back to this because it's where context rot begins, and it's the most neglected layer in most production systems. Layer 1. System prompt. The foundation, in amber here, because it's architecturally special. Agent identity, constraints, format rules. The most stable layer. It changes rarely, and it must be kept lean. The skill of context engineering is mastering all 5 layers, what belongs in each one, how they interact, and how to keep each of them focused, efficient, and clean. Let's go deep on layer 1, because this is where I see the most consistent and expensive mistakes in production. The golden rule, shown here in amber. Keep it under 2,000 tokens. Every token in your system prompt is a token that competes with your runtime context, the information that actually changes per task. If you burn your context budget on the foundation layer, you've compromised every layer above it before the task even begins. So what belongs in the system prompt? 5 things: agent role, persona, and constraints, output format specification, negative space decisions, and I'll come back to this in a moment because it's the most powerful and most overlooked technique. Pointers to context sources, and behavioral guardrails. What does not belong? Your project documentation that lives in your vector store, loaded on demand via layer 3. Your full conversation history, that's layer 2, managed separately. Rarely used edge cases. Lazy load them when the edge case actually occurs. And data that changes per request. Inject it dynamically in layers 3 or 4. Now, negative space decisions. This means explicitly documenting what the agent should not do, and why. We use the Anthropic SDK, not OpenAI. Here's why we made that decision. We use REST, not GraphQL. This is the single technique that has saved my teams the most time. It prevents the agent from confidently suggesting approaches you've already evaluated and rejected, session after session. Document the negative space. Your future self will thank you. Layer 2 is where context rot begins, and it starts with what I call the junk drawer problem. Shown on the left. What most teams do is treat the context window exactly like a junk drawer. Every turn gets appended. Every API response. Every error. Every back and forth. All 47 previous turns. Raw API responses that are 10 kilobytes of noise. Everything just gets thrown in and sent with every new request. The model buries the important information under layers of accumulated garbage. Attention dilutes. Performance degrades progressively. Costs spiral as context windows balloon. And nobody notices until the agent starts making bizarre decisions on turn 50 of a long workflow. That's context rot in action, and the result is always the same. Attention diluted. Costs spiral. Agent fails. The context engineering approach on the right is different across 5 specific patterns. Rolling window. Keep only the last n turns and auto-trim older ones. Simple, effective, immediate improvement. Compression. Summarize earlier turns into a single dense paragraph. The agent gets the key facts without the conversation archaeology. The /compact command in Claude Code. Run it every 60 to 90 minutes in long sessions. It preserves key decisions while freeing up space for new work. Decision log. Preserve architectural decisions as explicit stated facts, not buried somewhere in a 40-turn thread that the model has to excavate. State object. Serialize the current task state as a structured object. Send that instead of reconstructing it from a full dialogue replay. The goal is never to give the agent everything that happened. The goal is to give it exactly what it needs to know right now to continue the task correctly. Layer 3. And this is where I see a lot of architects stop too early. The 77% stat on the left is striking. 77% of IT leaders now say RAG alone is no longer sufficient for accurate, reliable AI in production. And they're right, because RAG is one retrieval pattern within a much wider landscape. Let me walk you through the 6 retrieval types shown in the grid. Vector search. Your semantic similarity baseline from Pinecone, Weaviate, or PG Vector. This is table stakes. It's not context engineering. It's a single operation within Layer 3. Episodic memory. Per user history. What this specific user has done, decided, and asked before. This is what makes agents feel personalized, rather than generic. Semantic memory. Your team's curated knowledge base. Policies, domain facts, the things that don't change per request, but that every agent needs to operate correctly in your domain. Procedural memory. How-to knowledge. Runbooks, skill patterns, standard operating procedures. The things the agent can reach for and reuse, rather than rederiving from scratch each time. Code and schema. Live codebase files, database schemas, API specs. These should never be burned into your system prompt. Load them at task start, specifically the files relevant to the current task. Live tool results, web searches, API responses, database queries that happen mid-task as the agent discovers it needs more information. The skill is knowing which retrieval type to use for which information and loading the minimum necessary at the right moment. Layers 4 and 5, the 2 runtime layers, and both have critical patterns that most teams get wrong. Layer 4, tool results. The rule is inject, don't preload. Tool outputs enter the context at execution time, never up front. But there are 4 specific patterns under this that matter in production. Inject, don't preload. Tool outputs at execution time, never up front. Validate before injecting. A malformed or oversized tool result can derail the entire agent reasoning chain. Add a validation step between the tool call and the context injection. Summarize large payloads. And this is critical. A 10 kilobyte API response must become a 200 token structured summary before it enters the context window. The raw response contains 98% noise. And version your schemas. When your tool API changes, downstream agents that depend on that tool's output structure need to know about it, or they break silently in ways that are extremely hard to debug. Layer 5, user message. The layer everyone focuses on. It is 10% of the problem, as shown here. The context surrounding it is the other 90%. The real work is extracting structured intent from the user message and using that intent to trigger the right context, loading in layers 1 through 4. And the security note that I can't stress enough: sanitize all user input before it reaches higher layers. Prompt injection through the user message layer, where a user deliberately crafts input designed to manipulate your system prompt or retrieval layer, is a real and underestimated attack vector in production systems right now. Phil Schmid at Google DeepMind formalized 4 operations that I now consider the fundamental vocabulary of context engineering. If you leave this video remembering one framework, make it this one. Operation 01. Write. Persist context externally. Nothing important lives only in the context window. It vanishes at the end of a session. Write to vector stores, relational databases, or files. Build institutional memory that accumulates and compounds over time, rather than starting from scratch every single session. Operation 02. Select. Retrieve only what's relevant. This is your full retrieval strategy. All 6 types from the previous slide. The key insight here is that precision beats recall. Irrelevant context is worse than no context. It dilutes model attention and introduces noise directly into the reasoning chain. Less, but more relevant, is always better. Operation 03. Compress. Summarize and compact. This is the operation most teams skip entirely, and it's why their agents degrade over time. Context rot, the silent accumulation of irrelevant noise, is the most common cause of production agent failures I've seen. Compress on a schedule, not when performance degrades, before it degrades. Operation 04. Isolate. Separate contexts per agent. In multi-agent systems, give each agent only the context its specific role needs. The 2026 research confirmed what the theory predicted. Shared context creates coupling, and one injected falsehood propagated to 100% failure across an entire system. Role boundaries are trust boundaries. Treat them as such. These 4 operations, write, select, compress, isolate, are the complete mental model. Everything else in context engineering is a specific implementation of one or more of these. This is where context engineering stops being a nice optimization and becomes a hard engineering requirement. The quote at the top from Phil Schmid at Google DeepMind is the axiom I return to constantly. Most agent failures aren't model failures. They're context failures. Think about what this actually means architecturally. In a single-turn interaction, bad context gives you a bad answer, but you can iterate. You see the output, you adjust, you try again. In an autonomous agent running a 50-step task, orchestrating API calls, writing files, querying databases, making sequential decisions, the context you load at the start is all it has. Look at the note at the bottom of this slide. Agents can't be reprompted mid-task. The context loaded before execution is everything. A missing piece of context at step 1 cascades silently into a completely wrong outcome by step 50, and you often won't know it until the task is done. The life cycle shown here, 5 stages, is how I design every agentic workflow. Preload first. Assemble the system prompt and relevant memories before the agent starts. Retrieve. Fetch task-specific context dynamically via RAG or tool calls. Execute. The agent acts, and each tool call injects new context at that moment. Compress. Summarize completed steps and drop irrelevant intermediate results to prevent context rot mid-task. And finally, persist. Write important findings to long-term memory before the session ends. That final persist step is the one almost every team skips. And it's why every agent session feels like starting from scratch. If you're building multi-agent systems, this slide is the most important in the deck. The research finding at the top changed how I design every system. The From Spark to Fire paper, published in 2026, studied context propagation in multi-agent hub and spoke topologies. The finding: injecting a single falsehood into a hub node in LangGraph caused 100% system-wide failure. Not some errors, not degraded performance. Complete failure across every downstream agent. Compare that to leaf node injection, which caused 9.7% failure. The topology of context flow determines your blast radius when something goes wrong. That's not an edge case. That's a design constraint. So how do you design for this? The 3-role pattern here illustrates the principle. Orchestrator agent gets the high-level goal, the subtask decomposition plan, the agent roster and their capabilities, and the output schemas it expects back. What it does no T get: the internal reasoning traces of subagents. That's noise at the orchestrator level. It creates cognitive overhead without adding value. Coder agent gets the relevant code files, the coding conventions doc, the current task specification, and the error from the previous run, if this is a retry. What it does not get: business logic or user context. That's irrelevant to its role, and loading it wastes tokens and introduces confusion. Validator agent gets the coder's output to validate the test suite and expected results, the quality criteria checklist, and prior validation failures. What it does not get: the original task prompt or user message. That information could bias its validation toward confirming what was asked for, rather than objectively assessing what was produced. Role-based context isolation is not just good practice. It is the difference between a system that degrades gracefully under error and one that catastrophically cascades a single bad data point into total failure. Let me bring this to something concrete you can implement this afternoon. The terminal window on the left is a minimal CLAUDE.md file. This is the most practical context engineering tool available right now, and it's criminally underused in most teams. Walk through what's in it. Project context first. Your stack, your architecture pattern. Python 3.12, Fast API, PostgreSQL, event-driven architecture. Just the facts the agent needs to know about the environment. Then conventions. Snake case, type hints required, test structure. These aren't just style preferences. When the agent knows your conventions, it stops suggesting patterns you'd have to rewrite. Then, highlighted here in red. What not to do. Most important. This is the negative space section. Don't use synchronous DB calls in async functions. Don't import OpenAI SDK. We use Anthropic. These 2 lines alone will save hours of corrections over the course of a project. Then context sources, marked as lazy load. Not the content of those documents, just the pointers to them. The agent loads them when it needs them, not up front. And finally, current sprint. 1 line. Focus, agent observability pipeline. That single line reduces irrelevant suggestions more than almost anything else. The 6 reasons on the right are why this works. Every session starts with the same baseline. Architectural decisions prevent drift. Negative space stops repeated mistakes. Lazy loading keeps the system prompt lean. Sprint awareness focuses suggestions. And every developer and every agent on your team gets identical context. This takes 30 minutes to set up. The ROI starts immediately. 6 failure modes. Naming them makes them much easier to spot and fix before they take down a production system. Context rot. 01. The silent killer. Accumulated irrelevant conversation turns progressively dilute the model's attention. The fix is aggressive compression on a schedule, every 60 minutes in a long session, not when you notice performance has degraded, because by then, the damage is done. Context overflow. 02. Injecting too much data and leaving no room for actual reasoning. The most common version is passing raw API responses directly into the context window. A 10 kilobyte payload must become 200 tokens. Summarize before you inject. Always. Context stale. 03. Loading data at startup that changes during the session. Product prices. User session state. Tool schemas after a deployment. These need to refresh at runtime, not be captured once at session start and assumed to be valid for the entire task. Context coupling. 04. In purple. Sharing full context between agents in a multi-agent system. We just saw the 2026 research on this. One false node caused 100% system failure. Isolate contexts by role. Build explicit trust boundaries between agents. This is not optional. Context injection. 05. User input that manipulates your system. Prompt or retrieval layer. This is an active attack vector, not a theoretical one. Sanitize everything that comes from untrusted sources before it reaches higher context layers. Assume adversarial intent at every boundary. Context blind spot. 06. The most insidious. Assuming the model will figure out missing context based on implicit knowledge it doesn't actually have. It won't. Not reliably. Models hallucinate under ambiguity. If the agent needs a piece of information to complete a task, you must explicitly provide it. There is no, it'll probably figure it out. Every production agent failure I've debugged traces back to one of these 6. Know them by name. I want to spend a slide on something that causes real confusion in architecture discussions. People using RAG and context engineering as interchangeable terms. They're not. The three-column layout here is the clearest way I've found to show the distinction. On the left, what RAG only does. It retrieves from a vector store. It focuses specifically on the select operation. It handles document chunking and embedding and similarity search at query time. RAG solves one specific layer of one specific problem. In the middle, the overlap. Relevance filtering, token budget awareness, runtime injection. These are techniques shared by both. On the right, what context engineering also covers that RAG doesn't touch. System prompt architecture, conversation compression, episodic and semantic memory, multi-agent context isolation, tool, result formatting and injection. That bottom banner says it definitively. RAG is a technique. Context engineering is a discipline. RAG is one tool inside a CE system. Not the same thing. This distinction matters because if you try to solve agent failures by improving your RAG and nothing changes, you might conclude the problem is unsolvable. But you've only addressed one layer of a 5-layer problem. Larger context windows don't solve it either. More capacity without better curation just means more room for noise. I've seen 1 million token context windows perform worse than 128K windows when the context was poorly engineered. The 4 stats here are the numbers you need when this conversation moves from the engineering team to leadership. 95% of data teams plan to invest in context engineering training this year. This is no longer an experimental discipline. It's entering the standard skill set. 89% plan to invest in context management infrastructure in the next 12 months. The tooling, the vector stores, the observability layers. The investment is following the recognition. 40% of enterprise applications will embed AI agents by end of 2026, per Gartner. That's up from under 5% in 2025, an 8-fold increase in 1 year. Every one of those deployments needs context engineering to work reliably in production. And 82%, back to this number, say prompt engineering alone is no longer sufficient. That's not a fringe opinion. That's the majority of technical leaders in organizations that are actually shipping AI systems. The bottom line, shown here, is direct. The senior AI engineer roles at the top of the market right now. The 200,000 to 312,000 positions go to the engineers who understand how to build production-grade context engineering systems. The engineers who don't will be outcompeted by those who do. This is the most important skill shift in AI engineering in 2026. Let me make the impact concrete with a single scenario. The instruction to the agent. Write a quarterly business review for Q1 2026. Without context engineering, shown on the left. The agent has a prompt and nothing else. It produces a generic template filled with placeholder data. It has no knowledge of your actual company metrics. It doesn't know the CFO prefers charts over tables. It doesn't know about the Tuesday board meeting deadline. The output requires 8 to 10 manual correction rounds before it's remotely usable. That's not an AI output. That's a starting point for a lot of manual work. With context engineering, on the right, before the agent starts, the right context has been assembled. CRM data, Jira sprint outcomes, the CFO's format preference, the current date and the Tuesday deadline, all injected across the appropriate layers. The output pulls actual Q1 metrics from the CRM automatically. It formats everything as charts because the CFO preference is in the context. It references the Tuesday board meeting because the date context is there. It cites specific Jira epics because the sprint data was retrieved from layer 3. The draft is deployment ready in one pass. That is not a marginal improvement. That is the difference between a tool that generates work for you to fix and a system that generates work you can actually ship. And the only difference between those two outcomes is context engineering. A quick map of the tooling landscape. Because knowing what to reach for is half the implementation battle. 4 categories shown here. Vector and memory stores. Pinecone for managed vector search. Weaviate for open source multimodal retrieval. PG Vector if you're already in Postgres and want to keep your stack simple. Redis Stack for sub-millisecond retrieval in latency-sensitive applications. Agent frameworks. LangGraph leads here with 27,000 monthly searches per LangFuse's 2026 framework data, and it's the right choice for complex production orchestration. Crew AI for role-based agent teams. Anthropic's Agent SDK for Claude native systems. Google ADK if you're GCP native. Context protocols. MCP, Anthropic's Model Context Protocol, has matured significantly and is now the standard interface for connecting agents to external tools and data. Google's A2A protocol enables agent-to-agent communication. IBM's ACP provides enterprise governance. These 3 protocols together are the primary reason 2026 is the year agentic workflows are actually moving from demos to production. Observability. And I'd argue this is the most underinvested category. LangFuse for LM trace and context logging. OpenTelemetry for distributed tracing. Grafana for agent workflow dashboards. And Datadog LLM observability for cost and latency monitoring at scale. You don't need everything here. Pick one from each category suited to your stack. The observability layer especially. You cannot improve what you cannot see, and most teams are flying completely blind on what context their agents are actually receiving. Here's the concrete implementation path. 3 weeks. You're not rebuilding your entire system. You're adding context engineering to what you already have. Week 1. Audit. Before you build anything, understand what you have. List every place your team writes system prompts. Identify what context is missing that causes failures. You probably already know where the agents are struggling. You just haven't framed it as a context gap yet. Map which data sources your agents actually need access to versus which ones they have now. And establish a baseline. Count how many correction rounds a typical output requires. That number is your gap metric. It tells you how much context engineering headroom you have. Week 2. Build your context library. Create a CLAUDE.md for every active project. This is your first tangible deliverable. Document your architectural decisions and your negative space. Set up a vector store for your team's shared knowledge base. And define context interfaces for each agent or workflow. The explicit contract specifying what context that agent needs to do its job. Week 3. Instrument and persist. Add rolling window history management to your agents. Instrument with LangFuse or OpenTelemetry. You need visibility into what context your agents are actually receiving before you can systematically improve it. Create a long-term memory. Write step at the end of every session. And establish a context review cadence. I recommend updating your context library monthly as your codebase and team priorities evolve. 3 weeks, 4 concrete actions each week. Pick it up wherever you are. 7 things. These are the ones I want you to carry out of this video. 1. Context engineering is not prompt engineering. It's the entire information architecture surrounding the model. A completely different level of abstraction. 2. The system prompt is the foundation. Keep it under 2,000 tokens. Point to context sources. Don't embed them. 3. RAG is one technique inside CE. 77% of IT leaders say RAG alone is no longer sufficient. Treat it as one tool, not the solution. 4. Agent failures are context failures. Get the pre-execution context right, or the task fails end-to-end. There's no recovering mid-flight. 5. In multi-agent systems, context isolation is non-negotiable. Shared context equals shared failure modes. The 2026 research proved this conclusively. 6. Context rot is silent and deadly. Compress proactively. Don't wait for performance degradation to tell you something is wrong. 7. This is now a career skill. 95% of data teams are investing in CE training. The engineers who already understand this have a compounding advantage over those who are just catching up. The gap between knowing this and not knowing it is the gap between building AI systems that work reliably in production and building systems that look impressive in demos and fail in the real world. 4 actions. Not a reading list, not a research project. 4 things you can actually do starting today. First, create a CLAUDE.md for your most active project today. Not this week. Today. 30 minutes. The ROI is immediate and it compounds with every session. Second, audit one failing agent workflow for context gaps. Take one workflow that's been giving you trouble. Walk through the 5 layers. Ask which layer is missing or broken for this specific task. You'll find the problem in under 10 minutes, and you'll have a concrete fix you can ship this week. Third, add a single compression step to your longest running session. Just one. A rolling window, a /compact trigger, a state object serialization. Pick whichever fits your architecture. Watch what it does to output quality over a long session. And fourth, share this video with one engineer on your team who needs it. The teams that adopt context engineering as a shared discipline, where everyone speaks the same vocabulary and uses the same patterns, outperform teams where only one person knows it. Dramatically. If this was useful, then like, share, and subscribe Quantum Tech Sage. One deep dive per week. I'll see you in the next one.